Kia ora, Year 11, 12 and 13. Here are a couple more questions from yesterday's integration paper. So I'm going to do question 3C and 3D in the one video. So 3C is quite a nice question, I think, and a little bit different from some other ones. We have to find this integral. So we want to find the integral between 4 and 1 of x plus 1 plus x over x plus 1 dx. So let's have a look before we get into it. The x plus 1 bit here is going to be fine. When we see the x plus 1 in the denominator, we should be thinking about the natural log of x plus 1. But what's mucking that up a bit is that we've got x sitting here in the numerator. But the derivative of this thing down here is just 1. So it's not going to be a completely straightforward backwards chain rule because this is kind of extra, unwanted extra stuff. So what we have to do is to rewrite the x over x plus 1 to give us what we need. So let's try that now. So if we rewrite it like this, and if we've got x plus 1 here, the numerator of x is the same as x plus 1 minus 1 dx. Okay, so why does that help us? Well, what we can say now is that we've got, I'm doing this really slowly in case you haven't seen this pattern of question before, we've got x plus 1 over x plus 1 minus 1 over x plus 1 dx. And of course this is just 1. So now we've got the integral from 4 to 1 of x plus 2 minus 1 over x plus 1 dx. And we can integrate that really easily. We're going to get a half x squared plus 2x minus the natural log of x plus 1, evaluated at the limits of 4 and 1. Now I haven't finished this off on my calculator, so I'm going to do exact values. And when I do that, this is what I get. I get a half of 16 plus 8 minus the natural log of 5 minus a half plus 2 minus the natural log of 2. And when I clean that up, I'm going to skip this step because I'm pretty sure you can do this but yourselves. I get 27 over 2 plus the natural log of 2/5. You don't have to write it like that. There was nothing in there saying exact values, but that's what I would do, and then I would go and chuck that into my calculator. Of course, you could chuck it in your calculator here if you wanted. All right, on to 3D. So we're given a derivative, and we're basically given coded information about the constant of integration. Right, so how does this one go? Well, we start off with dy by dx is equal to 4x over 4x squared minus 3 plus root x is x to the power of a half. So integrating that will get me y. So y is equal to the integral with respect to x. And again, we've got a natural log popping up in here and a pretty simple fractional power. So this is the first step of the problem. Now the denominator of 4x squared minus 3 has a derivative of 8x. We don't want exactly 8x, though. We've got 4x up here. So this integrates to give me 1/2 of the log of 4x minus 3 plus 2/3 x to the 3 over 2 plus c. Right, what information have I got to help me figure out that plus c? Well, I know that y of, what did we get given? Y of 1 is equal to 2. So I'm going to substitute in x equals 1. So 2 is equal to 1/2 log of 4 times 1 squared, so 4 minus 3, plus 2/3 plus c. Now the natural log of 1 is 0, so we get 4/3 is equal to c. Right, so this is 0, this is 6/3, this is 2/3. That gives me, for the function, y is equal to 1/2 of this natural log plus 2/3. I'll write that back as a third, x to the power of 3 over 2 plus 4/3. And then we've got y evaluated at x equals 4 is what the question, just skimming back up here, we're asked to find y evaluated when x is 4. And again, I'm not going to finish this on the calculator, but we get 1/2 of the natural log of 4 cubed, which is 64 minus 3, so natural log of 61, plus 2/3, and 4 to the power of 3 over 2 will give me 2 cubed, which is 8. So it's 2/3 of 8 plus 4/3. So we get 1/2 log 61 plus 20 over 3. That's my exact value, and you can go and pop that into your calculator and figure out what it is. I'm sure someone's going to let me know if I've made any mistakes in there. I have done those questions pretty quickly, and I haven't checked them, but hopefully they're all good. Thanks for watching. I'll probably try and do a few more questions in the next few days, but no more tonight.